This week we are talking about Chapter 8, which deals with confidence intervals. So we're going to start by talking about any sample statistic is what we call a point estimate, which is just what it sounds like. It's an estimate of a specific data point. So it could be the mean or the median or the standard deviation. Anything like that is a point estimate. And I mentioned in last week's oral lecture that we don't know when we have a sample, we don't know how close to the true population statistic or parameter that we are. So what we want to do then is develop a confidence interval, which is an estimate within a range of values, and it increases the likelihood that we're correct because we're guessing within a range. And we can then estimate the percentage probability that our interval actually contains the true population parameter. So we're not going to know how close any specific number is, but we know when we can identify a range, the percentage, the likelihood that the true population parameter falls within a certain range. And that range is defined by a lower limit and an upper limit, just like any other normal range would be. In criminology, criminal justice, it's pretty standard to see either a 95% or a 99% confidence intervals. So in other words, we want to know with 95 or 99% certainty that the true population parameter falls within the specific range that we identify. There is a possibility that we're wrong. So if we're talking about a 95% confidence interval, then there's a 5% chance that we're wrong and that the population parameter falls outside of that range we've identified. In the 99% confidence interval, there's only a 1% chance that we're wrong and that the population parameter lies outside of that interval. But with the 99% confidence interval, it's a wider range. Where a 95% interval, we're still pretty certain that we're right and we're even closer to being accurate because we have a smaller range. So whatever we set the confidence interval at, and most of the time you're going to see 95 or 99%. If you take that percent minus, if you take 100% minus that percent, whatever you set the confidence interval at, that's our probability of being wrong. So if we set it at 90%, then there's a 10% probability that we're wrong. In research, we're only willing to accept a really small amount of risk, which is why we see 95 and 99% confidence intervals most commonly. That one minus the confidence interval, so that 5% or 0.05, or that 1%, which would be 0.01, expressed as a decimal, is called alpha. And your book shows you the symbol for alpha. It looks like that, I think it's the Darwin fish or something, but that's what the symbol looks like. And it's called alpha. Make sure you don't need to follow the book's calculation or memorize it, but just make sure that you know the critical values in the Z distribution for both the 95% and the 99% confidence interval. You should just memorize them. There's only two numbers. With the 95% confidence interval, the critical value is plus or minus 1.96. And with the 99% confidence interval, the critical value in the Z distribution is plus or minus 2.58. So again, just memorize those. Your book takes you through how to get the calculation, and it should make conceptual sense to you, but you don't need to memorize how they obtain the calculation, and you're not going to be asked to do that specific calculation for either distribution. So just make sure you know what the critical values are, plus minus 1.96, plus minus 2.58. You absolutely have to know how to calculate confidence intervals. The end of your chapter, the end of chapter 8, gives you a bunch of different examples and tells you to calculate the confidence interval. If you're uncomfortable with it, or if you just want the reinforcement or the practice, I would highly recommend doing those calculations. I think that my textbook is the same as yours. I don't think it's a specific instructor edition. If I'm correct about that, then the back of your book will have the answers to those review problems, so you can look them up to see if you're correct. If I'm wrong about that, and I do have an instructor edition that has the answer, because I know for sure my book has the answers in the back. If yours does not, let me know if you do practice problems and just say, hey, can you shoot me the answers for questions 1 through 8 at the end of chapter 8, and I can shoot you those answers. And I'm also happy to do that for any review problem at the end of any chapter if your book doesn't have them, but I think that your book does. But in any case, I would recommend definitely practicing those calculations. It is imperative that you understand how to calculate a confidence interval and also how to interpret the confidence interval. So if we're looking at the average time that inmates spend in solitary confinement, and we want to set the confidence interval at 99%, let's say that we get the interval of 20 months to 33 months. So 20 months is the lower limit and 33 months is the upper limit of the 99% confidence interval. The way we would interpret that would be to say there is a 99% chance that the actual mean time that all inmates, in other words, the entire population of inmates serving time in prison, spend in solitary is between 20 and 33 months, which is the lower and upper limits. There is a 1% chance that the true population mean is either less than 20 months or more than 33 months. In other words, outside of that range. So the big things for chapter 8, make sure you understand, make sure you memorize the critical values. Make sure you know that in our discipline, we typically set confidence intervals at 95% or 99%. Make sure you understand alpha, which is the percentage possibility that we're wrong, which is just 1 minus whatever we set the confidence interval at. And make sure that you understand how to calculate and how to interpret confidence intervals. I think with this material, it might be a little bit, you might need to focus on it a little bit to fully understand it, but I don't think it's especially confusing or hard. I think that conceptually it's actually one of the easier things to understand in statistics. Especially for as far along in the course as we are. But just make sure that you take the time to really digest and understand the material, because I think if you don't, then unless you're pretty familiar with it, it can be a little bit confusing or overwhelming. Again, you're not going to be required to memorize formulas. You will be required to apply them, though. As always, let me know if you have questions or if you would like me to show you anything additionally. I'm always happy to add some stuff. I can always do these Zoom videos. I can provide you with resources. I mean, however I can help you, please just let me know. I'm always happy to do that.